Hello guys, welcome on Tesla Adventures. In this video today, we'll be discussing the level 1 problems of rectilinear which are based on motion under the effect of gravity as well as on the equation of motion. And obviously this is the level 1 problems which are based which are for JEE mains and Neet. Now you can see that in the first problem there is a particle A which is moving with a constant acceleration from A to B in such a way such that at point B its velocity is V and at point A its velocity is U. C is the midpoint of A and B, and therefore let us assume that the distance from A to C is the distance from C to B, and we have to find out this velocity V dash or VC. So first of all, you can see that if we use the equation of motion, which is third equation of motion, so V square will be equal to U square plus 2AS, and V square will be U square plus this is 2 into A into 2S. So you can see that V square minus U square is equal to 4AS. Okay, this is first equation. Now if we use the same equation of motion for motion from A to C, then Vc square is equal to Va square plus 2As. So Vc square is equal to U square plus 2As, and 2As is V square minus U square by 2. Okay, so you can see that Vc square is equal to V square by 2, and this is U square by 2 with a positive sign. Okay, so Vc is equal to under root of V square plus U square by 2. So the correct answer is option A. Now we move on the next question. In this problem, you can see that there is a stone A which is dropped from a height h from the ground, and at the same point stone B is projected vertically upward with the velocity v. We have to find out the value of v so that they both meets just at the midway. So midway is h by 2. So we have to find out v. So you can see that in equal time they will meet at this point and they are projected at the same time. So to find out the time taken by this stone to move down by a height of h by 2, so the formula is 2 under root h by g. So we'll substitute the value of h as h by 2 and this is g. So this would be under root h by g. This is the time it would take to move down by a distance of h by 2. Now let us see that this is the same time that B would take to attain the height of h by 2. So for B we are writing down the second equation of motion, which is S is equal to ut plus half a t square. So S is h by 2 and U is V and t is the time, which is under root h by g, and this is minus because V is in the upward direction and I have taken the upward direction as positive, and g is in the downward direction, therefore the downward direction would be negative. So this is gt square and t square would be h by g. So h by 2 will be equal to V under root h by g minus h by 2. So V under root h by g is equal to h, and V square or V is equal to under root of gh. So the correct answer is option C. Now let's move on the next question. In this question, you can see that there is a ball which is thrown up in the vacuum and it returns down to the ground in 12 seconds. So we have to find out the time in which its position is same as that was at 5 seconds. First of all, let us draw that this is V, this is U, and the time of flight of this stone is t is equal to 12 seconds. Now let us see that at some time it is at this point A, and this time is equal to 5 seconds. Okay, now it ascended and again attained this level of b. So we know that the time, this is t1, and the time in which it will again attain this height is t2. So we know that t1 plus t2 is equal to time of flight. So we can say that t1, which is equal to 5, plus t2, which we have to find out, and the sum of these two times is 12. So t2 is equal to 7 seconds. So this is the time that stone will take to again attain this same height. So the correct answer would be A. Now we move on the next question. In this problem, you can see that a particle is starting from rest and has a constant acceleration of 4 meters per second square for 4 seconds. Then it retards uniformly and comes to rest in next 8 seconds. So first of all, we have to find out the average acceleration during the motion. So we know that the formula of average acceleration is v final minus v initial upon time taken. Obviously, this object is starting from rest and finally it came to rest. So v final is 0 and v initial is 0 and time taken is t. So this is 0. So the average acceleration during this motion is 0. Now the average speed during this motion, you can see that the average speed v average is the total distance traveled upon time taken. Now you can see that it moved for 4 seconds with the acceleration of 4 meter per second square. So the distance traveled by this particle in the accelerated motion is half at square. So s1 is half, a is 4 and t square is 16. So it would be 32. And the distance traveled in the retarded motion can be calculated easily. We can first of all find out the velocity at the end of accelerated motion v1, which would be at. So at would be 16, and therefore finally in retarded motion the final velocity is 0. Initial velocity of the retarded motion is the final velocity of accelerated motion. So this is v1 square, and minus we don't know the acceleration, but we know the time that it came to rest in 8 seconds. So let us apply the first equation of motion. So v is equal to u, which is v1, minus a into t, which is 8. So a is equal to 2. Retardation is 2. Okay. Now to find out the distance, let us use v square is equal to u square plus 2as. So v square is 0, u square is v1 square, which is 256, 16 square, plus 2 into 2 into s2. So s2 is 256 by 4. So 256 by 4 is 64. So the total distance traveled by this particle is s1 plus s2, and therefore it would be 32 plus 64. So this is equal to 96. And the time taken is, total time taken is 12 seconds. So t is 12 seconds. So the average speed of the particle is 96 by 12. So 96 by 12 is 8, and this is the average speed, and therefore the correct option will be A. Now the average velocity is the displacement traveled upon time taken. You can see that this particle has never turned around. In fact, its initial velocity is 0. So it started its motion from rest and it accelerated for some time. Then it again came to the rest. Therefore, we can say that it never turned around and its direction always remained the same, which means that the average velocity and average speed are same in magnitude, because distance is same as displacement. So the average velocity will be also 8 meters per second. Now we move on the next question. In this question, you can see that a ball is thrown vertically upwards with a velocity of 30 meters per second. Its acceleration is 10, which is acceleration due to gravity acting in the downward direction initially. And we have to find out the distance traveled by that ball in the last second of its motion before coming into the hands of the thrower. So we know that if the initial velocity is 30, then the total time of flight of the ball will be 2 into 30 by 10, which is 6 seconds. And therefore, in last second of the motion, the ball, now we can use the fact that ball is at top point at 3 seconds and its velocity is 0 at this point. V is 0 and time is 3 seconds, and then ball is descending down. So the total time taken by the ball in downward journey would be 3 seconds. So the last second of this downward journey is the third second. So in downward journey, we are applying the equation S is equal to U plus half A into 2n minus 1, which is the distance traveled in the nth second. So S in third second will be 0 because initial velocity is 0, and plus half G is 10 and 2 into 3 minus 1. So S of third second is equal to 5 into this is 6 minus 1, which is also 5. So the distance traveled by this ball will be 25 meters in the last second. So the correct answer is third. Now we move on the next problem. In this question, you can see that there is a block which is moving down on a smooth inclined plane starting from rest at t is equal to 0. And S nth is the distance traveled by this block in the interval of time, which is n minus 1 to n. So we have to find out Sn upon Sn plus 1. So obviously, in the distance traveled in time t is equal to n minus 1 to t is equal to n is Sn. Therefore, the distance traveled in time t is equal to n to t is equal to n plus 1 will be equal to Sn plus 1. And the initial velocity is 0. It is given in the problem. So Sn will be equal to 0 plus half A into 2 n minus 1 and Sn plus 1 will be equal to 0 plus half A into 2 n plus 1. So Sn upon Sn plus 1 will be equal to 2n minus 1 upon 2n plus 1. So the correct answer is option B. Now we move on the next problem. In this problem, you can see that from a building of height h, there is a particle which is thrown vertically upward direction with a speed u. The time taken by that particle to hit the ground is n times the time taken by that particle to reach the highest point. So we have to find out the relation between h, u and n. So let us see that there is a there is a particle which is thrown from a building of height h in the upward direction with velocity u. So the total time taken by the particle to reach the ground is equal to the n times of the time taken by the particle to reach the highest point. So let us suppose that the time taken by the particle to reach the highest point is t1. So t1 we directly know that t1 would be equal to u by g. And to find out the t2, which is the total time taken by the particle to reach the ground, this is t2. So this time can be calculated by using second equation of motion. Now if we use the second equation of motion, then we can see that from this point, starting from this point and ending on this point, the net displacement is minus h, because the net displacement is in downward direction and its magnitude is equal to h, and the velocity, initial velocity was u in the upward direction, which I have considered to be positive, and this time t2 which it would take to reach the ground is n times of t1, which is n u by g, and minus half g into t square, which is n square u square by g square. Okay, so minus h is equal to n u square by g minus this is n square u square by this is 2g. So you can use this negative sign and you can write it, you can take n u square by g common, and it would be n by 2 minus 1. Okay, I have used this negative sign. So it would be 2hg will be equal to n u square into n minus 2. So the correct answer would be option number 3rd. Now we move on the next question. In this question, you can see that there is a parachutist which jumped off from some height, and after descending down by a height of 50 meters, he opened the parachute and he deaccelerated with acceleration of 2 meters per second square. Okay, now we have to find out the height from which he jumped off from the ground, and we know that he reaches the ground with a speed of 3 meters per second. So let us draw the situation that initially he jumped off from this point, let's suppose A, and this is the ground, and after jumping, after descending by 50 meter, we can see that its velocity v will be under root of 2gh. So it is under root of 2 into 10 into h is 50. So this will be equal to under root of 1000, and therefore it is 10 root 10. Okay, now when he will reach the ground, he will reach with the speed of 3 meters per second, and this height, remaining height is h minus 50, and in this journey he was deaccelerating with a acceleration of 2 meters per second square. So let us write down the third equation of motion, which is v square is equal to u square plus 2s. So v square is 9 and u square is 1000, and this is minus 2 into s. So 4s is equal to 981, in fact 991, and s is equal to 991 by 4, and s is actually h minus 50. So h is equal to 991 by 4 plus 50. So this 991 by 4 is approximately 247, and this with 50 is approximately 293, which can be easily calculated if we take g as 9.8. So now we move on the next problem. In this problem, you can see that a car started from rest and accelerated with a constant acceleration of f through a distance of s, and then moves continuously for time t with the same speed, and then deaccelerates with the rate of f by 2 to come to rest. The total distance traveled by the car is 15s. Then we have to find out the relation between s and t. To solve this problem easily and quickly, we can draw its velocity time graph, and we can see that its VT graph would be like that, because it accelerated and then it moved with the constant velocity and then it retarded to 0. So its acceleration was f initially, and let us suppose that this is v0, which is the maximum velocity attained, and this time is t, let us suppose t1. Then it moved for a constant time, time t with a constant velocity v0, and then it de-accelerated and came to rest with a de-acceleration of f by 2. So you can see that this time t2 can be calculated by the fact that this tan theta is equal to, or we can say that if we find out this equation, then v0 is equal to 0 plus ft1. And if we apply the equation of motion in this motion, final velocity is 0, and this is v0 minus f by 2 t2. So you can see that v0 is equal to ft2 by 2, and that v0 is ft1. So t2 is equal to 2t1, which we can find out. So I can write it down as 2t1. Okay. Now the distance traveled in the first part is s. So you can see that s will be equal to, or we can say that v square is equal to u square plus 2s. So s, we can use the second equation of motion, s is equal to ut plus half at square. So s is equal to 0 plus half is f, and time is t1 square. Okay, for the first part. And for the third part, we can find out s3. So s3 will be equal to ut minus half at square, or we can directly use the equation number 3. Okay, so let us first of all use s is equal to ut plus half at square. So s3 is equal to u, which is the initial velocity, or we can use v square is equal to u square plus 2s. This would be more convenient for the third part. So you can see that v is the velocity v0, which is under root of 2, acceleration is f, and displacement is s. So final velocity is 0, initial is v0, and minus 2 into f by 2 into s3. So s3 is equal to v0 square by f. So v0 square is 2fs by f. So it is 2s. And the remaining distance is traveled with velocity v0, and this s2 is equal to v0 into this t. Okay. Now you can see that total distance s1 plus s2 plus s3 is 15s. So s2 is equal to 15s minus 3s, where s was the distance s1 and s3 was equal to 2s. So total s1 plus s3 is 3s. So s2 is 12s. So 12s is equal to v0, which is v0 is under root of 2fs into t, and squaring both the sides, 144s square is equal to 2fs into t square. So cancelling this s with s, so you can see that s is equal to t square by f t square by 72. So the correct answer would be option 3. Now this was the last question of this level 1 problems, and there are many problems which can be formed in level 1. So you can now practice on yourself, and you can use this video by pausing it at every question and solving it by yourself, and then moving forward. In the next video, I'll bring the level 2 problems of this type. Thank you.